you to our 16th webinar about asset integrity management. My name is Marcel Sminia. I'm a co-founder of Cenosco, and I will be facilitating today. In this webinar, we're going to look at the topic of field operations and discuss how to streamline those operations using modern tools to track tasks, document results, and simplify your work processes. Let me start by introducing our guests. We have invited two industry experts who will discuss these insights, Luis Corrado and Peter Poldervaart. Luis is an engineer with a postgraduate degree in safety and an MBA, with over 18 years of international experience in inspection and integrity. He's currently a business development manager and trainer at Cenosco. And Peter is a SIS domain expert with over 15 years of experience working in the oil and gas industry. Peter not only has domain expertise in SIS engineering, but also in SIS equipment, commissioning, maintenance, and field testing. Guests we had planned originally could not make it at the last moment, so Peter, thank you very much for stepping in. So before we start, let me just outline the framework of our discussion. We will start by looking at the current situation with field inspections, including workflow and various pain points. And then we will continue by looking at what can be done to improve the process of conducting field inspections and recording the results together with some of the barriers and potential benefits of new workflows. And to conclude, we will have some time to answer questions that we have already received a few up front, but please feel free to put any questions that you might have into the chat. And also please note that if for any reason you experience a bad connection on your end, you can refresh your browser and it will bring you back into the webinar. So let's get started. Hi, Peter. Again, thank you. Nice to have you on the webinar. How are you today?
Hi, Marcel. I'm good. Thank you. Nice to be here. Thanks for the invite.
And good to see you again, Luis. Almost didn't recognize you with your glasses. How are you?
Thank you. I'm doing good. Thank you for having me on this webinar, and a special thanks to Peter that is actually bringing quite an interesting value in field operations related to safety instrumentation, and I'll be complementing with the mechanical part. That's thank you, Peter, for joining and having me.
Okay, guys. So Luis, you've got almost 2 decades of experience in this field. Can you tell us a little bit about the current state of field operations, and more specifically, talk to us about the steps involved in conducting an inspection, test, maintenance, from planning to completion?
Yeah, thank you. So I think if you look at today's situation in field inspection, and then when I'm talking inspection, I'm talking about the QA of maintenance, but also the field testing of sensors and instruments in general. I don't think it changed that much since I started 20 years ago in the field, in the process that you would receive a package from a planner, right? You receive an instruction of what to do. You can call it a work order, or it can kind of an assignment, an inspection request. You get that documentation, those instructions, drawings, print it out, get them on paper, right? You get your notebook and go into the field looking for those equipment that have to be inspected. Bring your camera along, take a photos, writing it down, right? Sometimes you can have a checklist on paper, but you would probably you're very likely taking the annotations on a blank piece of paper. Once you finish the work, you take the annotations, you come back to the office, and you have to translate the data that you have acquired in a visual inspection, on a non-destructive testing, a functional test, or any other type of field work. You would convert that into a Word document, or you can, input that data into a system already. But I still see, even today, mature inspection organizations with mature assets that are still writing it down, inspection reports in a Word document, sometimes printing, scanning to contain the signature, and then saving into an inspection management system or into SAP, into a CMMS system. That's a situation that I've seen when I started. I've seen good companies that have that digitalize a lot, but I think the current situation, I think in general, in a lot of those industrial assets, it's still pretty much manual, right, Marcel?
Okay, so Peter, what can you add to Louis' description of the process? Have you noticed any significant changes in the last years?
Yeah, Marcel. So I think Louise did a great job outlining the broad steps in the process, and there are naturally going to be differences in the details of how these steps are implemented. Looking at SIS equipment specifically, different facilities may use different instrument types, instrument vendors, or different instrument hookups in the field. Inspection of SIS equipment may even be influenced by corporate or regulatory requirements. So with this in mind, it's very much possible that a facility in Texas will have different inspection reporting requirements from a facility in Thailand or Qatar. But ignoring those technical and regional differences, the core processes involved in conducting these field testing have remained fairly consistent over time. And although these processes have been effective at improving safety, reducing leaks, and reducing unnecessary downtime, I believe there is still plenty of opportunity to improve the processes to achieve even better results.
Okay, so Peter, before we get to talking about potential improvements to the process, in your role as SIS domain expert and experience in SIS equipment commissioning and maintenance, what are some pain points that you dealt with when it comes to field testing?
I can think of a few potential issues that we encounter on a regular basis. So one being paper forms. So prior to heading into the field, as Louis already depicted a little bit, an inspector prints out or copies the forms necessary to address each piece of equipment that you are going to test in the field. Although they have been used to complete inspections or document maintenance activities for ages, paper forms cannot respond to inspectors' inputs. They can't validate input and often cannot provide additional guidance to the staff that is doing the work in the field. Another issue with paper forms that is also widely known is that it often can't represent historical data, which is of immense value in supporting decision making in the field. Another pain point might be data entry. At the end of the day, when an inspection or maintenance activity has been done and documented on a paper form, those forms typically have to be scanned in or manually have to be re-entered into an asset integrity management system. So that leaves room for errors or omission of data. Because you have to go from one system to another, and it's people work, and people make mistakes or people forget things. So there is also a data integrity issue over there. And lastly, I would say lack of connectivity in the field. So due to the nature of the sites that we work at, many locations don't have wireless network access. And as a result of that, it's impossible for field staff to consult with their team or to access a database or to access a manual while they are doing this work in the field. So that could limit them, and that may also lead again to maybe misunderstanding or errors being made while doing the tests in the field. All of these issues lead to, I think, decreased productivity, potentially reduced safety, and slower decision making during the testing due to missing or incorrect data available. Marcel.
Yeah. Okay, so now let's talk about the future state. Louise, in the past, you've talked about the digital maturity framework. I think that might be relevant to this discussion as well. Can you talk a bit about the framework and where you think the industry currently sits when it comes to the collection of field data?
Yeah. So I've spoken about these digital maturity framework in the past, um, but let's see with the eyes of the collection of the data in the field, right? Again, the more mature you are, right, the more digitally strategic you are, the better will be the benefits, right? The better will be your technical assurance. The more will be your confidence that you're preventing failure. The more it will be your cost optimization. So the more profitable the asset will be. So the goal is to be digitally strategic. So where a lot of companies are pre-digital, right? They might have a sophisticated CMMS system, but it comes to collecting data in the field, yeah, they're still pre-digital, still a manual process of writing it down, long narratives and filling tables in in a Word document, right? So it's a text document. So that data cannot be crunched. If you want to review that, you have to read it and take your conclusions and then make an observation. So the pre-digital moved into that digitally reactive. So if you remember when I don't know, back in 2004, we got those hand palms, right? So we got the palm that a lot of companies were using to start collecting data in the field, but they were disconnected, right? So they were working as an isolation, and say you would need to key in the equipment identification, you would need to key in the inspection results, and it was reactive. So it was an industry or assets that said, I want to collect data in the field. What are the tools? I'll just pick one and let's start collecting. But that was not really integrated or connected with the overall process. So then the companies would be going into that digitally purposeful and say, what are the tools we need for the company to achieve its goals and address its business issues, right? Moving into that digitally integrated. Now you're doing an inspection, you're collecting the data. How are you going to integrate and share that data with other systems to allow a more in-depth analysis and understanding of the integrity issues for those assets, for those equipment, for example. Yeah, and then the digitally strategic is how we're going to have algorithms and AI and machine learning behind to contribute to the scope of a field execution, and how we're going to analyze that outcome in a more automated way with cutting edge technology. Where I think the company sits today, I still see companies that have a very sophisticated digital twin and a mature integrity management system with the corrosion calculations. But actually the field data, it's collected in a piece of paper, and that is handed over sometimes 3 times until it reaches a system in which the data will be used. So I think there's still a lot of companies in that pre-digital, digitally reactive, while their other systems are much more mature. So it would be natural for those companies using or performing field inspections to move along that maturity framework.
Yeah. So Peter, in the context of increasing an organization's digital maturity level, what are some of the features that you think will be valuable in the system for collecting data from field operations?
That's a great question, Marcel. Earlier I talked about the current state of things and some potential problems. So in my view, any digitized solution would be to do away with any paper forms and replace them for some sort of digital forms. In some cases, data is already recorded in Excel spreadsheets or other digital formats, but this suffers from the same drawbacks, really, as in a paper form, where the data needs to be transcribed or imported into yet another database. It would be ideal, I think, if the data collected in the field could automatically be synchronized with the asset integrity management database without any intermediate steps. So that would also reduce the possibility for error and omission. Another feature that would be beneficial while doing this testing is the ability to access historical data. Consolidating historical test results and failure mechanisms that can then be used to analyze equipment performance, and that can be compared with any assumptions made for that equipment during the engineering process. And lastly, I would say any digital solution would need to work on a mobile device with or without a connection to a Wi-Fi or cellular network. So ideally, the person that needs to carry out this test would download all the required information that supports his field test. Could be PNIDs, could be manuals for a sensor, anything that he possibly needs to access during that field test, and to complete his field test should be downloadable on that mobile device, so that he has access to it in the field whenever he needs it, Marcel.
Yeah, clear. So those are all good suggestions, I guess. Louise, can you think of any other features that would be beneficial in such a system?
Yes, I think elaborating a bit more on that digital forms, right, and getting a form or a checklist or a grid, and how to make that smarter, right, rather than just digitalizing a form straightforward. We can have a dynamic, it built dynamically, right? And by dynamically, I means a decision tree, and say, if you say I found corrosion, it should come, the second question would be a more specific question. What is the coverage of that corrosion? Yeah, and then you can qualify even more. So having a smart dynamic form, we call that dynamic form as a technology behind that field data collection, to guide the field workers, right? To give also them insights, built-in logics and validation rules. Let's say this checklist is only available for this type of equipment. Sometimes, you can link that to a specific process condition, to a specific degradation. So you can make a very specific checklist for specific situations, right? And have that guidance. So one is the guidance, that guided protocol with the decision tree and, the possibilities being explored. The other one is bringing to the hands of the inspector and the possibility to update that regularly, to show to the inspector what good looks like. And so you see on the right side is that bringing a guide to the inspector to say, which category of corrosion have you seen? Does it look like this? So this is a category A, right? It's a light scale. So you start quantifying and getting better quality data that is being generated in the system. So you get not only the right question, you get the right guidance to get the right structured data. And then finally, I think that's also very important capability is to, how do you come up with annotations? A lot of the inspection comes with images, right? And those images come with an annotation. You want to point exactly where did you find the crack or where you see an issue with the coating, right? So you can make that annotation directly in the mobile. I still had my old Sony camera that you would stick in a floppy disk, and then it would come back with the floppy disk and put in your computer, download the images, upload in the Word document. So having that capability to take a photo, in the field and annotate in the field, that actually adds a lot of value in the process. Not only the images, but I could use a drawing. Yeah, I could use even a 3D model. It's available, and make an annotation straight on there, right? Review process conditions in the field and say, okay, I'm going to inspect, but what is the required, what was supposed to be the temperature for these process, for example? So you can have live access to process condition if you have that connection. Yep.
Yeah. Clear. Okay, so now let's move to some of the potential benefits. Peter, we talked about where we are when it comes to field operations and where we'd like to be in the future. Can you talk about some of the benefits you see in moving toward a digital solution for collecting field data?
Yeah, Marcel. So there will be multiple benefits, I think, but there are three important goals that I would keep in mind, and that is to improve safety, ensure compliance, and maximize any return on investment. Looking at improving safety, I think that can be achieved through the completion of effective inspections and maintenance in the field. I mentioned that being able to access historical data pertaining to equipment has value in the field. With that information at hand, a field worker could identify potential leaks or failures early and deal with them before they become a problem. Louise mentioned responsive checklists, which can help flag issues automatically and guide field workers to complete the appropriate tests and measurements, reducing the need to return to site to complete additional work, for example. So this form can actually help you by ensuring that you complete all the essentials to complete the full test before you're signing off on that test. Or returning back to the maintenance building after completing your test. So it's a helpful tool, and that will improve safety because you know that you've completed the minimum steps as well. It can guide you, it can help you. And the next benefit is contributing to improving regulatory compliance. So we all recognize the risk associated with running afoul of regulatory agencies. A comprehensive digital solution to documenting field tests and field operations would be able to record all the necessary information to ensure compliance, including equipment condition histories, corrective action reports, review and approval documentation, and other service records. And it's all consolidated within this single database where everybody has access, and the regulatory authority can have a look at that database, and you've got that traceability and auditability in that database when you keep everything digitized. Lastly, an ideal situation to the problem of documenting this field test and field operations would help to maximize a company's return on investment. By quickly and efficiently flagging issues related to equipment, inspection, maintenance planners can help allocate the limited inspection and maintenance funds in such a way to maximize the uptime and reduce unexpected downtime. And I'll add to that maybe the time savings that are associated with having to re-enter data already collected is an enormous benefit in itself, right? So if you fill it already out in that digitized form, and when you come back into the maintenance building, that uploads automatically into your CMMS database. You don't have to do all this manual labor anymore of retyping, trying to find out what somebody has written down in his own handwriting, which is unreadable, not having to do all of these scans. So it's a big time saver as well, Marcel.
Yeah. So Louise, the collection of good field data is important for some of the reasons Peter mentioned, of course, but the potential benefits of collecting data don't end there, right?
Yeah, I think like Peter finalized in the re-entered the data already collected. In the inspection area, we call that as a primary data, right? So that's the first time you record the specific data, and ideally you should not play too much with that primary data, right? So if you're able to enter that primary data directly into a system, directly into a database that will be consumed, that's the ideal, right? So not only on the re-enter the data, but avoiding compromising that data, right? So every time you manipulate the data, there's a risk of changing, there's a risk of typo, there's a risk of making a mistake, and in many cases that mistake can lead to false positives, and actually lead to more complications. So if you get the mechanism that bring the data um, that is more reliable, that will give you straight benefits, and all the benefits will be building automations around that, right? So if you're now recording a data that that is a good quality, you can start using that data to trigger some specific automation, such as updating your barrier management system, right? So say I found a coating issue to a certain degree on that equipment, I can update the coating barrier, say, okay, this is compromised, and trigger some additional workflows and to trigger maintenance activities or a further investigation. A few data can be that inspection activity, but it can also be some verifications and reporting leaks or reporting leak saves, which is also part of a specific methodology that we work with, right? That quick access to information, not only giving the quick information to the inspector, but also giving a quick access to that information for the planner that needs to receive the outcome. For example, if you're in a turnaround, right, you're conducting a lot of inspections. If you have to inspect the inspector to come back to the office to process the report, combine the photos, review the results, and for the equipment to be closed, you can lose a lot of time. So if you accelerate that process of pushing the results into the decision maker, you can actually shorten the turnaround period. And if you just reduce by 1 day that turnaround, in many times it represents millions in additional revenue, because you restart early, you produce more. So I think those for me would be the additional key benefits of implementing more digitally mature tools for collecting data.
Yeah, clear. So there are obviously many benefits to moving to a digital future of the data collection of field data. Peter, can you think of any potential pitfalls or roadblocks to implementing this sort of solution?
Yeah, there is always pitfalls and roadblocks, right? So any change to mission critical processes can be challenging to implement. When moving from pen and paper to a digital model, there can be significant resistance, to adjusting a company's operating model. So if you're used to doing things in a certain way for a long time, it's really hard. It's really hard to change those routines and learn new ones. That would be hard on any organization. So that would be one pitfall that needs to be overcome during this transition process. So you would typically do that by providing additional guidance and training on this new way of working within this digital infrastructure. So that would be a requirement for all the staff involved. Good guidance, good training, so they can learn, to work within this effectively within this new digital environment. I would also say that good guidance and end user inclusion is required on the implementation aspect when implementing this digital model for testing, inspection, and test data collection. And that is because this digital model not only has to be fitted within, in these existing company processes, but it also has to be fitted into, in many cases at least, an already existing IT infrastructure. Also over there, there will be a change not just to the processes, but also to the infrastructure. And that needs also good guidance and inclusion of all the involved departments and people. And I would say, of course, as a pitfall, there has to be a benefit there, right? So typically a cost benefit. Cost benefit analysis will have to be performed to demonstrate why and how the move to this digital system will benefit the company, Marcel.
Yeah. Luis, can you think of other barriers or pitfalls or challenges that Peter didn't mention?
Yeah, I think also the time and the effort to implement it, it can be seen as a challenge. When you're talking about digital checklist, it's kind of, you think as a simple thing, but if you build a dynamic form and then you have a lot of new checklists to be configured in per side, that can be a kind of a challenge. We've been mitigating that by creating, giving to new users out of the box existing checklists for most used equipment types and degradation mechanisms and methodologies, right? So it comes out of that. So the time to train new users and to deploy that across organization, it might take some time, and also to take the benefit of that structured data, it might take some time. Yeah, it's not because you did the one inspection using a checklist in one exchanger that it will give you all the trends. So it might take time to allow you to trend, right? Like Peter mentioned about the bringing to rolling out the knowledge in inspection specifically. A lot of those inspection companies that do the majority of the field inspection, they have a high turnover, so they have new inspectors. So training them take time. Cost, of course, it has to be considered. Although all the calculations I've done to justify an investment, the return on investment is in every single way of calculating it, right? So there's going to be a cost related to the time spent to train those inspectors. You're going to have a hardware, right? You have a hardware and you have software. The hardware is going to be your mobile device, your tablet. Sometimes ATEX proof. That ATEX proof coverage will be a bit more expensive, and the software to configure, to deploy, and maintain it. But I think at the end, what can be painful is changing the workflow, right? Changing the way companies are doing things. I think that's what Peter also mentioned, more to reinforce that operating model. I call it as a procedure.
Yeah. So you think the industry is ready to start implementing these sort of systems, Luis?
I think the industry on the two sides, right? So the software industry and the asset owners. I think the industry in general, specifically the oil and gas, chemicals, there's been a strong drive to digitalize, look for efficiency everywhere possible. So we do see companies that have those digital transformation teams, and they are, putting the efforts to get things digitalized. But the field work is at the bottom of that pyramid, right? So that's the bulk work. We've seen a lot of companies digitalizing their performance management, their integrity, running RBI, how they're going to do corrosion calculations and how we're going to mitigate my risks. And the digitalization of the field data has been left to the end. So yeah, I think the industry is ready in general. The technology is ready. So the technology is there to accommodate that. But like I say, leadership and needs to take the decision and implement it and say, okay, there's no way back. We will implement. Hey guys, we have to adopt and we have to change.
Yeah.
We have examples of companies that implemented very quickly. They said, give me out of the box templates. We're going to start with that and we're going to start using immediately, right? So it was top down. A team was very proactive and eager to change it. And we have some others that, we've been working for a year and, there's a lot of complications and they want to get it perfect at the right time. Get the minimum viable product, get it going. And today, Cenosco has developed a very strong partnership ecosystem that can also help the users to configure and set it up. So we have big names with us. We have Max Grip, we have Wood, we have Capgemini, we have SGS, we have Kiva. So we have a number of partners that are, from the engineering area that can help our customers to get set up for that.
Yeah. So guys, it's time to conclude. I see it looking at the clock. I think that any serious organization should be planning to move away from pen and paper to a true digital model for data collection. Peter, do you have any final thoughts on that?
Yes, Marcel. So I think the old way of data collection, or maybe not the old way, but the way that most companies do it right now, with paper and pen, although it can be effective, it's not nearly as efficient and effective as it could be. That doesn't mean that we have to change the way that we conduct these field tests or these field operations from the ground up, but we can significantly improve and make more effective the data collection and recording side of things. There are many steps that we can use to migrate to digital solutions that will help us ensure this regulatory compliance, still improve on safety, while basically maximizing the return on investment on our facilities, Marcel.
Yeah. Luis, any final words from you?
I think we covered that extensively. I think my final words is let's get it implemented, right? So I think 2024 is there. The technology is there. There's a new generation of field workers that are eager to use it. The digital technology and the hardware and the software is already up to speed to get those implemented. And we have overcome a lot of those barriers, like with the connection and so offline capability, structure, checklist out of the box. So I think it's a time, the same way we say, conducting a risk-based approach or identifying the risks and looking at the hazards of any site is a foundational element, is a minimum threshold. I think now already the use of that technology for field operations is quite also almost mandatory or a minimum threshold.
Yeah, clear. Okay, guys, we've received a few questions. I'm sure we cannot handle all of them looking at it. So let's start at the top and see how far we can get going. But I promise everybody we will get back to your question. So here's one, Luis. How can digitizing field inspections lead to increased productivity in refinery operations?
So running a quick calculation, right? So if an inspector goes in the field and he works 8 hours a day, he goes back to the office and spend an hour back in the office to work his reports. That easily represents about, more than 10% of his time in doing reports. So if you have a team, a large refinery will have easily a team of 50 inspectors, right? That represents actually up to 5 FTE, full-time inspectors, right? That can be reduced. So it doesn't mean that you're going to get rid of those, but it means that you're going to put the equipment back in service quicker. and that reflects in the productivity. Not talking about the turnaround, right? So that's going to be massive, and that turnaround can that time that you leave the equipment open can be reduced even further.
Yeah. Okay. Next question I have here: how can the collected data be used to drive continuous improvement in field operations?
I'll take that. I like to bring that continuous improvement and apply that into a framework, right? So, for example, one of the frameworks that I think it's quite effective is that CMF, a corrosion management framework, which is a barrier management system. And then if you use that barrier management system, and those barriers will have a status, and those status will have an indicator. And that indicator will actually come from a field work, from data that's been collected in the field. So we're going to pre-crunch the data that's been collected, and we're going to update the framework. So basically, when the inspector comes back from the field, in my case, the corrosion engineer, we already see in his barrier management that he has a problem with a specific degradation mechanism. And then he can see how, what is the level of risk of that equipment has been affected, and how many other equipment has been affected. And that's the continuous process. Like, how are you going to feed that into your next planning? How are you going to reflect, update your RBI analysis based on the inspection result? How's going to be your confidence rating? So I think the outcome is, it can be, you can see that in different ways, but I think putting in the framework that will give that in continuous improvement.
Yeah. Maybe same sort of question. What are the benefits of using digital checklists over traditional paper-based methods, Peter?
Yeah, maybe I would like to have some words on that. Many of them were already discussed, but what I think is a clear benefit, if you have a digital checklist, then you can actually link that to an equipment type, right? So it's very easy that, whenever you have to do a test from the CMMS system, you can link that test immediately to that equipment type and to a certain procedure. And you only have the template of that procedure once in your system. So it's like a master that is being copied onto all of these different equipments that you have to do testing for. So you only have to maintain one master template, and it assigns it automatically. Yeah, so that is one of the big benefits. The other one is that once you digitize it, that means that you have any of those data that you collect from the field, you have that digitized back into your system again. So, and I'm looking a little bit at the SIS part and the closing of the loop part, for the SIS lifecycle. This is information that is very valuable, because certain failure modes and failures that you might have found during this testing, you can feed that back into your system. You can do some analytics on it, some data crunching on it. You can, for example, link that up with a dashboard that will show you certain trends of particular equipment, showing certain failure modes that you as a company, as a department, a maintenance department, can take action on, because it impacts the safety of the site, it impacts the safety of the people. So if you see certain trends because of all this collected historical data, you can proactively start acting on it before it becomes a problem. So that is something that I see as a very valuable, additional point of these checklists, digital checklists, Marcel.
Yeah, thanks, Peter. Like I said, we will probably not have time enough to answer all your questions, but let's see how far we get. We have a few more minutes. Here's one. After digital checklists, how do you see the next step in the digitization journey? Would it be easier if AI would take info from an equipment plate and store it in a form? Luis?
Yeah, it's a very interesting question that I'll probably take a little bit more time to elaborate and come with a better answer later. But for me, the next step in that journey is actually using that structured data. That's extremely valuable data that everybody's looking after to kind of start predicting and getting those prescriptive maintenance, because those are actually the condition of the equipment that cannot be obtained directly from a sensor. So for me, the next step in that journey is actually using the outcome. Maybe in the future, I don't think today, there's gonna maybe we're gonna replace that digital checklist with the chatbot, right? And say, hey, I'm checking these equipment, and the chatbot will give you what to inspect, for example, right?
Yeah.
But for now, I think the checklist is about using that data.
Yeah. And another one, Louise, I have here is, can we consider a mobile device that you could use for these checklists in the field? Do you have any recommendations on that?
So in our case, right, so I can talk about ours. We tried these apps that you publish in an app store or you download. The technology that we decided to use is a technology that you can use on a browser. So you don't have to install any app, and there's no limitation in the app in the actual hardware you're gonna use. If you want to use Android, if your company is more reliable on Android or Windows tablet or iOS, it doesn't really matter. Um, Technology is the same. The browser that we use and the technology we use to have it offline, it will be the same. Of course,
Yeah.
personally, we've been using very happy with the iPads, right? There's one question also that talk about ATEX, right? Being able to provide that ATEX safe equipment for field inspection. It's quite important. We know that iPad has been a success in the field. Unfortunately, the case to become ATEX, it's more expensive than the tablet, but that's in exchange of safety.
Yeah. Okay, let's do one more. Maybe Peter, you find this one interesting as well. Let's see. Can you talk a bit about SIS proof test in the field for the purposes of maintaining barriers?
Yeah, so basically, Marcel, the SIS proof test that you do in the field is actually because of maintaining that particular SIS barrier. So any automated digitized structure where you have this proof test, this SIF proof test or this sensor proof test, if you have that digitized and you feed that back into your digital your maintenance management system, that information, if you find any failure modes on a specific equipment type, you can feed that back into the SIS lifecycle loop. For example, I've talked before about the engineering process. In the engineering process, you make certain assumptions on the PFD or the failure rates of PFD of a barrier or failure rates of a sensor. So if you find any discrepancy, once you start collecting this data and once you start crunching this data, and you find any mismatch between the reality of things out in the field and the assumptions that you've made during the engineering process, you can feed that back into your your engineering process, your layers of protection analysis, your testing interval calculations in your SIF analysis. That will yield updated proof test intervals, for example, to ensure that you achieve the target PFD, probability of failure on demand, of your SIF barrier that you require as per the IEC requirements.
Clear. Okay, one more, because I know you'd like to answer this one, Louise. Can site admins create new dynamic forms?
Yeah, so just to close down, any user can create dynamic forms. If you're familiar with IMS, things have to be approved, and then you need to have a specific role for that. Dynamic forms can be created from the user interface in IMS, and we do have all the supporting guidance manuals, and also on the Cenosco Academy, there is a specific content teaching teaching users how to configure them and how to get the maximum of those dynamic forms.
So that's a yes.
Yes, absolutely.
Okay, guys. Well, I need to wrap it up. Our time has run out. Luis, Peter, thank you so much for this informative discussion. And again, Peter, thanks for stepping in. For all viewers watching, thank you for your time. Good to see you in such great numbers. Please take note that this webinar will soon be available to download from our website. And before we go, you see it on the screen, I would like to mention that we already are planning the next IMS webinar in July. So hopefully I see you all then. Thanks again and see you soon.
Thank you, Peter, Marcel.
Thank you, everybody.
Guys.
Thank you.
Bye.
Thank you. Bye.
Bye.